Students, welcome to my YouTube channel. In this video lecture, I am going to answer the last 10 questions remaining from DME chapter Keith Williams Radio Lab. So let's start. Question number 91. Aircraft position is 36 degree 15 minutes south, 178 degrees east. Okay. Variation is given to you. 21 degree west. Flight level is given. VOR is at different position 36 degree 15 minutes south but 178 degree west. Pay attention here. Variation there is given. We have to find out the radial at which aircraft must fly in order to get the accurate ground speed indication. So let's plot this diagram. 36 degree 15 minutes south, 178 degree east. So that means both aircraft and VOR at same latitude, 36 degrees south, 36 degree correction, 36 degree 15 minutes south. Okay. Our aircraft is at 178 degree east. UR is at this position, 178 degree west. That means considering this is your northern hemisphere, aircraft is to the west of VOR station, right? That means aircraft is situated on radial 270, but this radial 270 is with respect to true north datum. We need to know all radials in magnetic terms. So apply variation at VOR station. Variation here is 21 degree east. So when you apply variation 21 east, that means magnetic will be least, magnetic will be less than true direction. True direction is 270. When you subtract 21 from 270, you get answer 249. So that means aircraft is situated on radial 249 with respect to magnetic north datum. This is the correct answer. So on what radial must the pilot fly? The pilot must fly on radial 249. Let's say this is your VOR station. The pilot must be flying on radial 249 inbound, because ground speeds are accurate when you are flying towards the station, VOR DME station, or away from it. So you can either fly towards this station or you can fly away from this station, whatever, but the radial will be same. If you're flying inbound, radial 249, so you're going to set your OBS 069 in order to get a 2 indication. If you're flying outbound, radial 249, so set OBS radial 249 to get a from indication. Next. The maximum number of aeroplanes that can be responded to by DME is how many? So theoretically, it can be 125 aircraft. Okay, theoretically, if this aircraft are not scanning at high rate. Okay, not scanning at high rate. But we all know that some aircraft will try to achieve a lock on with the DME station. So practically speaking, 100 aircraft can use a DME station. What are the DME frequencies? They are from 962 to 1213 megahertz in the UHF band. In a certain VOTAC installation, that is VOR Takan facility combination, VOR is identified Sierra Tango November, DME is identified Sierra Tango Zulu. So in both identifications, the first two letters are the same. Last letter is different. For DME, it is Zulu. So whenever this happens, remember this point. VOR and DME stations are said to be disassociated, not associated with each other, when they are away from each other by 2000 feet, and but they serve the same location. So the frequencies will be paired, but the first two letters will be the same, and DME last letter will be Zulu. Okay, so the question has asked us, this means that the distance between the two beacons is excess of 600 meter or 2000 feet. Okay, option A is both transmitters are co-located, maximum distance between them 30 meter or 100 feet in terminal airspace. Outside terminal airspace like en route area control, it can be 600 meter or 2000 feet. And if it is even beyond that, more than that, then they will be called not associated. Okay. And in that case, the DME will be identified by letter Zulu. Next, how many aircraft will DME accommodate before reaching saturation? 100 aircraft. Next, what is the slant range error? For aircraft flying at 9,000 feet, DME 2,000 feet high, when the slant range is 12 nautical miles. The slant range error means the difference between slant range and ground range. So, let's draw this diagram. The DME station is 2000 feet high. Aircraft is 9,000 feet high. That means it is 7,000 feet above the DME station. It is 7,000 feet above the DME station. The slant range given to you is 12 nautical miles. You have to find this ground range, ground distance, horizontal distance. Using what theorem? Using Pythagoras formula. Now 7,000 feet is nothing but 7,000 divided by 6,000, 1.1 nautical miles. So let's consider this 1 nautical mile. Now when you apply Pythagoras, 12 square is 1 square plus x square. X square will be 144 minus 1, 143. So x will be root of 143, 12, approximately 12 nautical miles. That means the ground range is 12 nautical mile, or correction, it is, let's be accurate. The ground range is 11.9 nautical miles. Land range is 12 nautical miles. So the error between them is very minute. Still, it is 0.1 nautical mile. So the correct option here will be option A, 0.09 or 0.1. Okay, the closest option. This is how you do the sum. Okay, next. The nominal coverage of a DME station will be how much? So your aircraft is at 20,000 feet. So if your aircraft is at 20,000 feet, range will be 1.25 square root of 20,000. So square root of 20,000 is 141.4. Multiply that by 1.25. You get answer 177 nautical miles. When range is when you are at 25,000 feet high, the answer would be root of 25,000 into 1.25, 197. Here 1.25 root of 30k, 30,000 into 1.25, 216. In this case, range should be same, 216. So of all the options, the closest option is, so 190, 177, 210, and this is 216. The closest is Charlie. Okay, closest by 6 miles. Delta is closest by 14 nautical miles, right? So the closest is Charlie. Next. 98. Ground DME transponders respond at a frequency which is 63 megahertz, different from the interrogation signal. Meaning, your aircraft interrogator will transmit a radar pulse in the direction of the DME station at a particular frequency, let's say 1000 megahertz or whatever. The ground transponder will reply to this interrogation pulse on this interrogation pulse on a different frequency, and this frequency will be different from the interrogation frequency by 63 megahertz. That means the reply frequency can be more than 63 megahertz, so 1000 plus 63, or it can be less than 63 megahertz, so 1000 minus 63. Okay, so delta is the most suitable option. It can be above or it can be less than that. If a DME beacon becomes saturated by interrogations, that means at one time it can handle only 100 aircraft. In that case, it will reply to the 100 aircraft which are nearest to it. It will adjust PRF to cope with all aircraft, switch off identification, adjust the gain to reply to 100 strongest signals. So correct option is option delta. When a DME becomes saturated, it can handle only 100 aircraft at one time. That means it will only deal with those aircraft whose signals are the strongest, 100 strongest aircraft. So if it happens that if any aircraft signal becomes weakened, uh, uh, subsequently it will eliminate that aircraft and replace it with some good strong aircraft signal. Okay, so remember this. Last, the reason for using different frequencies for transmitting and receiving the DME system is to what? Is to achieve what? So DME is a secondary radar based on secondary radar principle, secondary radar operation, and secondary radar are based on different frequencies. One for interrogation and another for response, transponding. And this is done in order to eliminate ground reflections or ground returns. So the correct option here is avoid reception in aircraft of signals referring to other aircraft, prevent self-triggering, prevent overload, permit more channels in the systems. So to avoid reception of signals meant for other aircraft, we do not use different frequencies primarily. For that, we have made an arrangement called jittering, jittering of PRF, pulse repetition frequency. So the correct option is option Bravo. So that the receiver equipment prevents self-triggering of the receiving equipment by the transmitter, so that it does not get triggered by reflections coming from the ground or any objects obstacles. That is why we use different frequencies, so that automatically reflecting frequencies which will be on the same frequency as that of the interrogation signal frequency will automatically get eliminated. So this concludes our lecture. I hope you have understood all the 10 questions. Practice all these 100 questions multiple times. Read the theoretical chapter thoroughly, carefully. Mark the important points from that Oxford DME chapter. I have already uploaded a lecture in which I have marked those important points and given it to you all. So do that, revise them, and all the best. I wish you all the best, and I hope you get maximum marks uh, with respect to questions related to DME. I will also upload DME questions of Oxford Ground Studies for Pilots book, RK BALI book. So do watch those video lectures also. Watch all the lectures. Thank you for your time. Subscribe if you haven't yet. Share this video with your friends and like this video lecture if you have liked this. Like this video lecture if you have liked this video lecture. So hit the like button.